me get y'all, see where we left off. I don't think we did any of the back, did we? All right, so just to recall, we looked at these different identities. Make sure you get this filled out at some point. Like, it's gonna look like magic for sure if you don't just understand at least when we start changing stuff where these are coming from. Okay? We looked at just simplifying these expressions, meaning no fractions. If we can, we write it as like one expression together, and we try to get it a little bit simpler than what we started with. As we turn on the back is a little bit easier, in my opinion, because we kind of got a map towards where we want to go. So the difference in what we did in the do now and what we're about to do is, like for the do now, it might equal cosine squared x. And our goal would be able to prove why that is. So you would do what we just did to get cosine squared x, and you would say, this is how, these steps are how we get to cosine squared x. This is what these problems are. So you have two sides to these problems, a left and a right side. More times than not, you will want to verify, show your work, simplify these expressions on the left side to show how you get the answer or the expression in some cases that you get on the right side. So you at least know where you should end up at. So for instance, on this example 6, in this case, I would probably want to show how this left side can come out to equal what's on the right. So this is your answer that you're looking to get it into, but what you actually do in your work will be what we did in the do now, quoting identity, Pythagorean's identity, until you simplified it to look like the other side. And at that point, you'd say, oh, these two things equal, and I do like a little check mark to just show like, oh, this checks out, how you get your answer. So for this one, you're basically showing your work. Yes, these two things equal each other, but how? Showing your work is how you work these problems. Okay? We got some steps that, like, as you do on your own to try to help guide you maybe. This is stuff that we've been doing. But like I say, more times than not, you'll do the left side of the equation, but in reality, you can prove that the right side equals the left side, or vice versa. More times than not, the left side is the side you'll want to work on. And there are even some problems where you'll do a little bit of work on both sides, but one of the sides is where you'll do most of your work at. We'll even look at one of those problems. But most of these, left side is what you'll do your work on, make it equal the right side. We'll use the identities in step 2 like we've been doing. We may find a common denominator, or we may multiply fractions, or we may combine like terms, or do other algebraic things that you guys have been doing since middle school. All right? And then if you get stuck, think about changing all of your terms that you can to write it in terms of sine and cosine. And a lot of times you will see like things cancel out, or you'll be able to multiply things together. So refer back to here. And you might do this, and then you might go back up to step 2. So I might get 3. I've done these 3 things. I'm at step 4. Let me write it in sine, terms of sine and cosine. Then let me go back to step 1 and see what I can do. All right, so let's do some of these. All right, so first one, I don't like the negative angles, so if I turn over, I think I have a identity that deals with these negative angles, even odd functions, right? So if a function's sine or cosine or secant, the negative doesn't even matter, so I'll do away with it. So like in number 5, cosine of a negative angle will be exactly the same value as a positive angle. So I'm going to write cosine as just cosine x. Right? Then I also need to deal with the tangent. So instead of having the angle negative for tangent, I can just make tangent negative. So I'll take that negative for the angle and I'll put it in front of tangent and just make the whole function negative. So by that I mean I'll write it as negative tangent x. Right, then I'll write what I got. Should come out to, it's divided by sine x. And then this should equal 1. I won't write this equal 1, but my goal would be to simplify this until I get it to be just negative 1. Okay, so if I look at this right now, Um,
Why should we make tangent x and not cosine? I mean, tangent negative and not cosine.
because I was following the identity. So if I have cosine of a negative angle, in this case it was negative x, I can just write it as just cosine of a positive angle because the exact values come out to equal the same. So yesterday when we did like cosine of 60 was 1/2, cosine of negative 60 was also 1/2. I know I'm talking, does that make exact?
Yeah, why is tangent?
Well, tangent, well,
Okay.
these two are even, all these other ones aren't. So when they're odd, you can take this negative and just make the whole thing negative. So like if I was doing tangent of negative 45, instead of trying to figure out where's negative, I would just do negative tangent of 45.
Okay.
And the answer would be exactly the same. All right. Okay, so at this point, I might say, can I cancel anything out? Can I combine anything? Not really. So I'll probably go to step 4 and write it in terms of sine and cosine. This is already cosine, this is already sine. What can I do to this tangent to maybe get it in terms of sine cosine? So I use the quotient identity, and I can write tangent as sine over cosine. So let's do that. So not changing cosine x, that's going to stay the same. What I will change though is tangent to be negative sine x over cosine x. And then this is all divided by sine x. So I rewrote tangent to be these two things. Everybody okay with that? That's the quotient identity. I don't know, maybe I should start doing this. This was QI for quotient identity. Okay, does anything cancel now? If this is multiplication, right? Yeah, cosine divided by cosine, if I put all these together, would cancel out to be just 1. So I can cancel those two. Cosine divided by cosine will just be negative sine. Who said that?
Sage said that. The H was wrong.
Maybe it was out of context. Okay, so on top, I'm left with just negative sine. On the bottom, I'm left with just sine. Everybody okay? What does this come out to equal? Just negative 1. Was that what I was looking to get?
I guess so.
Yeah. So I just verified. I just showed you how the left side can become negative 1. So if you were doing this on paper or something, or we were doing this in class or on a quiz or something, this is what you would do. On Alex, I think you type what you would get, and then you just click which identity you use. Last one would be like algebra, I think. Yeah, you just do algebra. This was algebra. Yep, first one's even odd functions. Second one's quotient. Last one's just algebra. All right, questions on any of that? Okay, let's do the one below.
You're gonna skip number 6?
We'll go back to number 6. This one's like that last one. Let's do that again. Okay, so how would I rewrite sine?
Sine.
It's sine. So does the negative go away, or do I put it in front of sine?
Go away.
I put it in front because it's odd. So I'm going to change that to negative sine x times cotangent. Does the negative go away, or do I put it in front?
Put it in front.
I put it in front. So negative cotangent x. If it was cosine, I can make it go away. If it was secant, the negative will go away. For all the other ones, I just make the whole function negative. So at this point, I'd say, does anything cancel? Not yet. So I can't do any algebra. I'm working on one side of the equation. Can't do any algebra. I've done the identities. Now I'm ready for step 4. Write it in terms of sine and cosine. What can I change to be a sine / a cosine or both of them? Cotangent. So the quotient identity tells me I can rewrite cotangent as cosine over sine. So let's do that. Negative sine x times negative cosine goes on top this time, right? Sine goes on the bottom. And this is all over cosine x. Not cot, but cosine x. Thinking about taking a nap, I guess. All right, anything cancel? Because a cot is like what a kid sleeps on. Let's keep it. I said a cot.
Oh.
I said a cot.
Like you know,
Alright.
like you know the things with the metal legs and like the mesh thing that
Like-
little kids sleep on a decade.
Yeah. All right. Let's just keep going. Oh my goodness. So anything cancel? The signs cancel. Sine divided by sine will cancel to be just 1. So that leaves me with, and it's negative times a negative. So can I write as positive cosine?
Yeah.
Oh, yeah. You can change the negative cosine. Because it's one of them.
Do we have a question?
Wait, so you can change the negative cosine to positive because it's one.
No. This is negative 1.
Oh, so it was one.
This is negative 1 times negative cosine. Because this was negative.
Oh, so it takes the negative away. Okay.
Yes, a negative times negative makes it positive. We sure that makes sense? Okay. So negative times negative makes the top positive. Cosine divided by cosine is 1. That's what we were looking to get, so we verified it. Here we use even odd identity. Here for the purple we use the quotient identity. For this one we just did algebra and simplified to get 1. And if you look, 1 was what we were looking to get, so we verified how this can become 1. Guys have any questions? Okay, you feel okay? Not so bad? All right. All righty. Let's go back to number 6. A little bit different of a method. So, for this one, I'd say let's work on the left side. So we want the left side to try to see how it can equal the right side. So if you notice on the right side, do I have any minus signs? No, but I notice I got 2 terms over here. So my thinking or logic would probably tell me like, I probably need to make this one fraction, and then maybe I can combine everything and see what I got on the left side. So I don't know, you might want to make a little note for your stuff. A lot of times when you have these fractions, especially if it's 2 terms, you will want to get it to be just 1 term. So just 1 fraction. So I guess another way I can explain that is, let's say we had 1 over 2 minus 1 over 3. Can I put these 2 together the way they are? What do I need to be common?
The denominator.
Denominator. What would a common denominator be?
6.
6. So in other words, a common denominator in this case would be a denominator that has 2 times 3. It would have both of these things. So on the right side, the left side, what would I multiply the top and the bottom by over here? 3 over 3. What would I multiply this side by? 2 over 2. Okay? 3 divided by 3 is 1. That's not going to change the value of my fraction, multiplying it by 1. 2 over 2 is also 1. That's not going to change the value of 1/3 because I'm multiplying by 1. Now, I separate it like this so we can see in a second. But now my common denominator is 6. 3 times 2, right? I wrote it like this so we can see that we have a 3 times a 2 as our denominator. So long story short, the left side needed to be multiplied by the right side denominator. And the right side needed to be multiplied by the left side denominator. I write it like this to say, to get a common denominator for these two things, the denominator would need to have both of these things in it. So long story short, I would multiply this side by this denominator. Then I'll multiply this side by this denominator. Let me show you because maybe it's not clicking for some of you guys. So my common denominator is going to be 1 minus cosine x times 1 plus cosine x. This side needs 1 plus cosine x. So I'm going to multiply the top and the bottom of this left side by this denominator. Meaning I'm going to do 1 plus cosine x. Since I do it on top, I got to do it on the bottom. And then I'm just going to write what was on the left side. What I started out with was 1 divided by 1 minus cosine x. So now this denominator will have both of these pieces. I need the right denominator to have both of these pieces. Which one of these pieces is it missing? Does it have 1 plus cosine x? Mm-hmm. It does. So it doesn't need that. It needs this other one, which is this denominator. So I'm going to rewrite this side. Minus 1 over 1 plus cosine x. The blue is just what I started with. And now I'm going to multiply by what this denominator needs. So the blue is my problem. The orange is what I'm multiplying each side by individually. I could multiply each side by something different because essentially I'm just multiplying this side by 1. So the value doesn't change. Same thing over here. Value doesn't change. So now they both have the same denominator. This right side has a denominator of 1 plus cosine x times 1 minus cosine x. This denominator is exactly the same. So now I got a common denominator of both of these things. So I get to put them together. 1 plus cosine x, 1 minus cosine x. And now I can put all the top pieces together. All right, and to try not to confuse, I'm going to just distribute this negative here and just put it with this 1. So when we start distributing, it'll make more sense. So, because the negative, I can give it to the top or the bottom to make this negative. I'm going to just give it to the top, so when we start doing stuff, it'll make a little bit more sense. Okay, everybody feel somewhat okay? Do we have a question that we can ask yet? Or?
Where did you find the denominator and the second one?
The second one?
Yes. No, the one below.
Below?
Yes.
So for this side, I have a denominator, 1 plus cosine x, that's this, 1 minus cosine x. Does that make sense?
Oh, okay.
And if I look on the right side, it's exactly the same, is it not?
It is.
It's kind of like if I go back to these numbers, 3 times 2 is over 6 minus over 6. So this would be 3 minus 2, right? But I could also just make it 3 minus 2 over 6, right? What I did was I went from here to this. They both got a denominator of 6. Let me just put them together. Same thing here. They both got a denominator of this and this. Let me just put them together. That's a good question. Any other questions? Okay, so now we get to put everything over this. This one's pretty straightforward. What is this times 1?
The same thing.
this. All right, so I'm just going to rewrite it. 1 times 1 is 1. Cosine x times 1 is positive cosine x. That's the left side. Now I'll go to this side. So I got plus, but it's -1 times -1. What's that?
Positive.
I'm sorry, I said -1, but it's -1 times just the 1.
Negative.
So -1. Then I got -1 times negative cosine x plus cosine x. Everybody okay? Let's combine our like terms. 1 minus 1 is what? If this was x plus x, I would have 2x, right? If this was an apple plus an apple, how many apples do I have? 2. This is 1 cosine plus 1 more cosine. How many cosines do I have? I got 2, so I'm going to put them together. It's 2 cosine x. And then let's sort out the bottom. So I think when we were solving quadratics and working with like binomials, which is just 2 terms when we square them, if the signs are different, anybody remember what happens to the middle terms? They cancel, because it'll be plus something, minus something. They cancel. So this is what will happen here. The middle terms will go away. Say all that to say, all I need to do is first times first, 1 times 1. What's that? And then a positive times a negative when I do last times last will be minus. If this was x times x, it would be x squared. Since it's cosine times cosine, it'll be cosine squared. Now, I just fooled that. I could do outer times outer, -1 cosine x. Inner times inner, +1 cosine x. They would cancel. This is what I would get. So I basically just fooled that. But I knew the middle terms would cancel, so I saved myself a little time. We okay with how we got here?
Yeah.
All right, and we're about to get simple because this is a Pythagorean identity. Let's turn over and see which identity has cosine squared. And I'll say, is it 1, 2, or 3? For the Pythagorean's identities, because those are the ones that are squared. It has cosine squared?
First one.
First one.
Oh my god.
Right?
Yeah.
So let's see, what could I make it look like 1 minus cosine squared? Could I change this equation to make it look like that? 1 minus cosine squared? Could I subtract cosine from each side? So in other words, could I say minus cosine squared minus cosine squared?
Yes.
Is this not what I have on the other side of my paper? Did these two cancel out? So if I see this, what does this equal?
Sine squared.
Sine squared. So I can replace this with sine squared. Does that make sense? I could also go the other way, just for kicks. If I wanted to solve this for cosine, I would subtract sine squared. And then I can say this equals cosine squared. So like I say, you can change these equations around. Just make sure you get a true statement. So if I move cosine over here, I see that cosine will equal that squared. So let's do that substitution there. So I can substitute this with sine squared. I feel like I should write it somewhere around here. Let me just say I'm going to do sine squared using Pythagorean identity, and I can replace this. So
Why?
Use 6 for me.
Well, I was listening to like why are you changing it?
Because I don't like how it's like, I'm just gonna get one term. Instead of me having like 1 minus something at the bottom of my fraction, I just want something. So because this is Pythagorean's identity,
Yeah.
1 minus cosine squared equals just sine squared. So it helps me simplify it. Because I don't have 2 things on the bottom, I just have 1 thing on the bottom now. All right, so let's come down and write what we got. We're getting closer. All right, so we got 2 cosine x over sine squared x. So at this point, and I'm tight on space, so I'm gonna write on the board. If this was x times x, and I wanted to separate it, well, I just told you. But if I had x squared, I could separate it as just x times x, right?
Yeah.
So I'm gonna split this up into sine times sine, and then I'll be able to get rid of the fractions. Because right now, I can't make it cotangent, because cotangent is, quoting identity, cosine over sine, right? If I turn over quoting identity, cosine over sine. But this is sine squared, and this is cosine to the first power. So I can't do that. But if I split them up, and do it like this, I can group these 2 together and change it into cotangent. Does that make sense?
Yes.
Quoting identity,
Yeah, but
cosine.
it's still gonna have the extra sign.
Well, I can change that too.
Oh my lord.
What's 1 over sine equal? Cosecant. So I can do this as 2. And remember what my goal is. What's my goal to get it as? Cotangent times
2.
cosecant?
Yeah.
So this is gonna let me do that. This becomes cotangent. Sine's reciprocal is cosecant. That's how I get my cosecant. This is what I was looking to get. So I wrote it on the board because I don't have enough space to write this and this. I'm gonna just write this. But this is how we get here. Okay, even if it helps, you can even think about it as like, if we separated these, this is what you have. You need a placeholder of a 1. So then I can do the reciprocal problem. All right. Questions on like how we split it up like this? And then questions on how we go from here to here? You sure? Okay. I'm gonna erase it and write it on my paper. See, I'll do a different color so it doesn't look so jumbled. Okay, so they don't take this long. I obviously gotta try to explain it. We stop, ask questions. Feels like a lot. It doesn't take that long. It'll take some time as we start to do these stuff. You guys have any question on any of that stuff? So the key thing here is when we see 2 fractions, I want to try to get it as 1. In order to do that, I need a common denominator. So just take what's on the bottom of the denominators and multiply each side by whatever it needs on the bottom. Together, this needed to be my denominator, so I multiplied each side accordingly. And then from there, it's just like doing algebra, distributing, combining like terms, simplifying. And then when you write everything in terms of cosine and sine, you should be able to like start simplifying stuff. All right, let's do one like this again. It's a little similar. Hopefully this one won't take as long. Okay, so it's a similar situation. I got two fractions. I only want it as one fraction. Okay, are the denominators the same?
Yeah, no,
What's different?
plus and minus.
This one is minus sine x. This one is plus sine x. To get them together, what would my common denominator have?
Sine,
It would have both of these in it, right?
yeah.
So I'm going to multiply this side by this denominator. I multiply the right side by this denominator. That'll give me a common denominator. So the left side, and as we go, like you won't necessarily write this step out, because you'll just see the pattern and you'll do it every time. So I'm gonna write it out. This side needs 1 plus sine x. I'm gonna do it on the top and I'm gonna do it on the bottom so I don't change the value of it. Then I'll write the left side that I started with, 1 minus sine x. Then I'll go to the right side, 1 over 1 plus sine x. So this one already has 1 plus sine x in its denominator. It needs this in its denominator. So I'm going to multiply both sides by what it needs, 1 minus sine. This is left side, this is right side. Do they have the same denominators now? 1 plus sine x times 1 minus sine x. Same thing over here. So now I can put them together. They both have a common denominator. All right, that's my common denominator. Let's combine my top terms. On the left side, 1 plus sine x times 1. That doesn't change, does it? 1 times 1 is 1. Sine x times 1 is sine x. Right, and then just for simplicity, I'm going to give the negative to this 1. So then I can just distribute the negative 1. What's negative 1 times 1?
Negative 1.
Negative 1. What's negative 1 times a negative sign?
Positive sine.
Good job. Plus sine x. Do I have any like terms I can combine?
Yeah, no,
I do.
yeah.
What about the numbers? What do the numbers sum up or come out to equal? 1 minus 1?
Huh?
$1, take away that dollar. How many dollars do you have? 0? And then how many signs do I have? 1 sign plus another sign is 2 sine x. And then since the signs are different, the middle terms will cancel. What does first times first give me? 1. What about last times last? Sine squared. What should the sign be?
Negative.
Negative. I think this is an identity. What would this equal? So I go to Pythagoras. Since it's squared, I know the Pythagorean identities is squared. I'll go to the one that has sine. And I'll go back to it so you can finish writing it. I see sine squared plus cosine squared equals negative 1. How would I change this equation to get 1 minus sine squared? What would I move over? I need 1 minus sine squared. would I subtract sine?
No. Yes.
I would.
Mhm.
And that comes out to equal what? If I move sine over, what's left?
Cosine.
Cosine. So 1 minus sine squared will equal cosine. So I can write that. Right, and then like before, I'll need to split up this cosine. So I can have sine over one of the cosines. And then one cosine will be on the bottom by itself, but then I can find the reciprocal. And at this point, I would be like, what's my goal? What am I trying to get it as? Tangent. But what's tangent? What goes on top with the tangent? Yeah, S.
S.
For sine. Yeah, sine over cosine. So that'd be one of them. And then I have one cosine left. What's cosine's reciprocal? Secant. So that's how I'm going to get that secant. So one more step, and I verify how this can be simplified to look like this right side. I've already got my 2. Let me get my tangent. The tangent will be the sine x over one of the cosines. That's how we get tangent of x.
Paper, please.
I can, I'm sorry about that. The other one will be cosine x. Because it was cosine squared, so I split them into individual cosines. And then we said that reciprocal was secant. So what I got is 2 tan x secant x. All right, so in reality, I probably should have got one piece of paper, did all this, and just lined up all my steps so we can see what we did each step. All right, first we did some algebra. So I would click the algebra button to get a common denominator. Then we did more algebra to get like terms. And we foiled here, so that was more algebra. Right here, which identity did we use to change 1 minus sine squared to cosine squared? What identity was this?
Q.
Was it quotient?
P.
P, Pythagorean. Pythagorean's identity. This equals cosine squared x, so I substituted. Here we use the quotient to get tangent. Here we use which identity to get secant?
Q. P. Flip. Change. Keep finished.
We do flip it. You flip it, that's finding the reciprocal. All right, we use reciprocal identity. Quotient identity is reciprocal. That's how we get here. All right, let's do one more, and then we'll spend the rest of the time letting you ask questions, thinking about it, starting on the homework. And we're going to spend a few days like doing this. We're not going to rush through this. We'll come in Friday. We'll look at some more of these problems. You'll probably have time to do homework. I hate to just give you a bunch of problems, but I feel like this is one of those things where we actually need to do it more times than a couple times to actually get it. So we're not going to rush through this. So don't panic if you don't got it today. We'll try to straighten some stuff out in a few minutes. And then even next week, we'll spend some time making sure we can do these. All right? So just another method. And we'll hold off on number 10 because number 10, it's not hard, but you work on both sides. And I feel like we need to get used to like thinking about these things before we try to do both sides. So we'll probably hold off on this one until like another day. But we actually need to work some of these first so we can start just, I don't know, getting our brain to like wrap around some of this stuff before we start trying to do both sides. This one isn't difficult. If you get through this one and you feel like you want to try to do it, go for it. But you will work on both sides. It'll make your life a little easier. All right, so let's go to this one. For this one, it's a little bit easier if we simplify by multiplying by the conjugate. So for conjugate, we talked about that. I know if we talk about something over a week ago, we just kind of throw it in the dumpster. So look at what a conjugate is real quick. If I had x minus 2, the conjugate is similar except something changes. Anybody have idea what's the one thing that changes with the conjugate? I mean, the x is the same, the 2 is the same. What's the one thing I didn't write? It's going to be a plus. So these two would be conjugates. The nice thing about a conjugate is the middle terms cancel, so this would become x squared minus 4. What would the conjugate of x minus 3 be?
X plus
X plus 3. What is the only thing you changed? The sign. So, why do we use conjugates? When you were in algebra 2 and you were dealing with like rationals, square roots in the denominator are imaginary numbers, you might have had something like 2 minus I. And the only way to get rid of that was to multiply by the conjugate.
Oh, yeah.
Coming back a little bit. That was a very good sarcasm. That was pretty good. All right. I actually believed you for a second. All right. And this would cancel out the i's. Some of you may recall I squared. Anybody remember what that is by chance? I squared? I squared? Nobody? I squared equals -1. 2 times 2 would be 4. So the bottom would come out to equal 3. All right, I'll stop. You guys don't remember doing that stuff?
I didn't do my work last year. No, my teacher didn't teach us.
last year.
Gotcha.
Hush.
Okay. But a conjugate is the bottom, only thing you change is the sign. Okay? So what would jump out at me to start this is, I see the right side is squared, nothing on the left side is squared. So if I'm working on the left side, at some point I'm going to need to somehow convert this to being squared. Only time you could do that is if you did the conjugate of both sides. That's going to be like sine times sine, which will give me sine squared. It also square the top, which will also like help me get to being squared, because I see this right side is to the second power. So I'm going to multiply the left side by the conjugate. So we're going to work on the left side, and we're going to try to prove that the left side can equal the right side. Right? So what would the conjugate be? And for the conjugate, I look at the denominator. What would the conjugate of the denominator be?
1 minus sine.
1 minus sine x. So I'll do 1 minus sine x. I'll do it on the top, so I also got to do it on the bottom. What I already had was 1 minus sine x on top, 1 plus sine x on the bottom. The orange is what I'm starting with. The purple is what the conjugate was. That's what I'm multiplying by. I'm not going to write the right side because at the end my answer should end up being the right side. Guys got any questions yet? Okay, so is this top the same as this top?
Yes.
It's the same. So it's 1 minus sine squared. So I'm going to just leave it like that for now. 1 minus sine x squared. The same thing on top, I'm just going to square it for now. Right, okay with that? Now, since the signs are different, I don't have to completely foil it. I know the middle terms are going to cancel. So all I need to worry about is first times first, last times last. What's first times first? 1 times 1. Since the signs are different, when I multiply last times last, it'll be negative, right? What's sine times sine? Squared? Sine squared. We saw this before, I think, on the last one, didn't we? What did this equal?
Co something.
cosine squared, right? Just like the last one. So Pythagorean theorem says I could change this to cosine squared. Okay, that'll make my life a little easier. So the top not changing yet. 1 minus sine x squared. And then using the Pythagorean identity, I'm going to substitute cosine squared with what was on the bottom. Everybody okay with where the cosine squared came from? Pythagorean identity. We sure we okay with that? So now, the top is squared, the bottom is also squared, right? So, if I rewrite it, I'm basically squaring the whole thing, meaning 1 minus sine x over cosine x is all being squared. And I'm thinking about my end goal. Notice how everything's in the parentheses and the squared is just on the outside. So I'm almost where I need to be. I just don't want any fractions, but I think I can deal with that. What will sine over cosine be? Quoting identity. Sine's on top. Tangent. Don't I need a tangent? And then I'll have 1 over cosine. What's cosine's reciprocal? Secant. So that's how I'm going to get these two things. 1 over cosine will end up being secant. Sine over cosine will end up being tangent. So one more step and we're finished. Okay, so I'm going to write it separated. These are, like before, we started off with 2 things, 2 fractions, and we made it into 1. I'm going to go backwards and separate these into 2 so I can work with them individually. So I'm going to change my color so we can see the separation. First part I got 1 over cosine x minus sine x over cosine x. So I just separated them so I can work with them individually. We said this one's secant, right? Reciprocal function, reciprocal identity. And then what did we say this one would be? Sine's on top. Tangent, just to be clear. Sine goes on top, quotient identity for tangent. All right, there you go.
Can you scoot it towards you for the reciprocal?